All right, so now we go into the biological aspects of psychology. So we're doing the brain. Some slides I'm going to tell you don't worry about, so just follow through. All right, so we're going to start off first with the smallest unit of the brain. The smallest unit is called a neuron. Okay, your neuron is the smallest unit. When you look at a neuron, it has different parts, and you need to make sure you understand the function of the parts. So you've got billions of these, and this is the way that your body communicates with the brain. All right, this part right here is called your cell body. Okay, it's your cell body. Extending from the cell body, you have what are called exons. I usually tell people these are like your arms. When you try to give me something, you extend your arms, correct? So your exons actually send information out. Extend information, send information out are done by the exons. So when the cell body wants to send information, they use the exon. When they want to receive information, they use the dendrites. To receive information, they use the dendrites. Send information, exon. Receive information, dendrites. You follow me so far? Are you good? Good. On top of this, you have what are called coatings. It's like a protective coating, which is called the myelin. The myelin sheath is a protective coating on your exon and dendrites. The myelin sheath is a protective coating on your exon and dendrites. Protective coating on your exons and dendrites. Okay. In between each of these, you have what is called the synapses, or the synapses gap, or synapses. You'll hear it called different things, but no, it's the fluid that goes in between the neurons. Synapse, or synapses gap. You need to know the myelin between each neuron. It's just fluid in between neurons. It's the space in between neurons. All right, you have afferent and you have efferent neurons. When we talk about afferent neurons, you're literally saying that this information is sent to the spinal cord and the brain. So when we talk, remember we said this is how we communicate with each other. So when we talk about one, you're literally saying we're transmitting information from your sensory receptors to the brain. So you touch something hot, it's your afferent neuron. When the brain needs to tell the body something, it's your efferent neuron. Make sense? Different types of neurons do different things. One communicates with the body, and then the other one has the body communicating with the brain. You touch a hot plate, which neuron is going to tell the brain you touched the hot plate? Afferent. The brain tells the hand to move, which part of the neuron tells that? There you go. Don't worry about your neural impulse. Don't worry about your firing. You do need to know all or none. All or none, the principle behind all or none is that the entire neuron must be functional or the neuron does not work. Pretty simple. Either all of it has to work or none of it works. All works or none of it works. If one part is broken, detached, not firing, the whole neuron is ineffective. It is a dead neuron. Dead nerve ending, which means you can put your hand on a plate, hot plate, and not feel it. Make sense? All right. We just talked about synapse. Keep it moving. Neurotransmitters. The neurons actually produce neurotransmitters. Neurotransmitters are actual chemicals that are released into the body based on the neuron. They are chemicals released into the body based on the neuron. They release different types of chemicals to do different type of things. And we're going to talk about the ones that they actually release to perform different things, different duties. Acetylcholine, or what we call ACH, is actually a neurotransmitter produced into the bloodstream to help memory, Alzheimer's, paralysis. So literally when your body or when you're trying to remember things, neurotransmitter will release this chemical into the body. Does that make sense? Got it? This is literally when you're trying to remember anything, neurotransmitters, the neuron literally starts to pour this chemical into the body to intensify some type of memory. That's one of them for memory. That's going to be the catch. There's a couple of them for memory. It's prevalent in memory. It helps. It aids in memory. You do want to know it controls muscle contractions. Muscles contract. Say it again. Oh. Dopamine. Dopamine is a chemical released into the body. It actually controls all your pleasure, involuntary movement, learning, and again, memory. Now, this memory is a little bit different. This memory is when you are trying to learn something. The other memory is when you're just trying to remember something. Do you see the difference? I know that sounds really close. Learning to remember and just trying to remember. Yes, when you're trying to learn to remember, it's a little bit more activity, it's a little bit more active. When you're trying to just remember, you're trying to link some stuff together. Acetylcholine is really just memory, like when you're just trying to remember things. Dopamine, learning to remember. You're trying to learn and remember some things. Some of you struggle with some dopamine production. When you just keep sitting there like, I can't get this, it's your dopamine. Sorry to tell you. It's just the chemical is not producing. Okay? I'm not going to go through all of them, but what you need to start looking is you've got all these different ones. I'm going to definitely tell you about serotonin because it's something that we talk about a lot of times. You hear a lot of people talk about serotonin blockers or what we call SSRIs. People who suffer from ADD and ADHD actually have a problem with the production of serotonin. They produce too much. So in turn, we give them SSRIs, which blocks the production of serotonin so we can balance the attention out. Does that make sense? If you ever take Prozac, Zoloft, because you have anxiety, you produce the wrong amount of serotonin. We're then going to give you an SSRI to block the production of serotonin. It can do both. It usually produces, it really slows the chemical down from production to where you're not producing as much chemical. So like when we take a blood, unfortunately, ADHD can be tested by blood tests. All we got to do is test the serotonin levels. But because they don't take all of that, they just literally take activity instead. We actually misdiagnose it a lot. And that's why they don't do it. Because if a person is affected by aggression, depression, insomnia, serotonin levels are going to be irregular. So you can't, it's like it works, but yet it doesn't work. Does that make sense? So if you're ever depressed, it's a lack of serotonin. If you can't sleep, what do they give you? What's the natural supplement they give you? Melatonin. Because they're trying to balance the serotonin that you don't produce with the melatonin that you can take over the counter to create a sleep pattern. Make sense? Eating disorders also. Eating disorders are literally a chemical imbalance. Anorexia or bulimia are actually chemical imbalances. Okay? Alcoholism, chemical imbalance. This is why it's now listed as a disorder. Okay. Endorphins, we will talk about this. Anybody here exercise, workout, do those things? What happens when you really get into it? What do you start feeling? Endorphins, what do you start feeling personally, like inside? You feel good. It's a high. You're literally high off of your own body. Okay? Endorphins are literally like a morphine. It is your body's morphine. So the more intense your workout, the more endorphins you produce, the more higher you get. Okay? Yeah, you won't get high like cocaine high. Just like minor high. The only problem with it is like after you've been doing it for so long, your body starts to get used to it to where you kind of don't even get it's almost like, it's like the drug. You take cocaine so long, it doesn't have the same effect after so long. Endorphins also, if you ever heard a person who get injured in a game and continue to play the whole game with a broke leg, they can continue the whole game because endorphins kicked in. I've heard of people being shot and keep moving. Why? Endorphins kicked in. They're your natural painkillers. Okay? So whenever the body feels like it's in pain, endorphins kick in and creates a natural painkiller. Another time that you create the most endorphins ever in time is during an orgasm. That's why it gives you the glow. You're really high. If you if you reach an orgasm, which we'll talk about in another chapter. All right, everybody got the neurotransmitters? You've mastered them. You're going to see examples and you can pick them out with no problem. Silence has fell again. I got the please don't let her look at me looks. I don't know what she's talking about. I'm just going to keep writing looks. Okay. You want to study those. I usually tell the best way to study your neurotransmitters as you're doing things throughout the day, just literally start calling off what the neurotransmitter is responsible. Okay, everything you do today is going to have a neurotransmitter present. Even if you feel sleepy tonight and you can't go to sleep, you better say which neurotransmitter is not letting you sleep. Okay, start talking to your body. You know, like serotonin please, whatever you got to do to remember, but do it and you'll remember things faster. Does that make sense? Don't call the wrong chemical out and be all messed up. All right, got it? Because we just started it. Yes? All right, good. Let's keep it moving. We're now to the nervous system. So we've got these neurons that need to talk to the body. The body now has a nervous system to where it does all of the production. And we're going to divide the nervous system into a couple of parts. We're going to start with the central nervous system. The central nervous system consists of the brain and the spinal cord. The central nervous system, brain and spinal cord. Now, when we talk about the brain, what does the brain do for the body? So what doesn't the brain do for the body? What doesn't it do? I hope it do. I'll be jacked up. I hope it does everything. Some of y'all might really feel like you lacking some brain activity. That's fine. But some of y'all, you know, you're sitting there like, I wish it worked. It sometimes lacks, but it technically does everything. Okay? You often hear people say we only use a percentage of our brain, blah, 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 blah. You use a percentage of your intelligence, but you use all your brain. Does that make sense? All right. Now, for the brain to talk to the body, it has to go through the spinal cord. So the spinal cord is literally the highway of information. The spinal cord is the highway of information. Oftentimes you hear if anybody said they broke their spine or did any kind of damage to the spine, some other part of the body is going to be affected because the brain cannot communicate with that body because of the spinal injury. Okay, hence paralyzation, hence not being able to speak, hence not being able to walk. Any type of damage that's done to the spinal cord can affect other parts of the body because the brain cannot speak to that part of the body now because of spinal cord. That make sense? All right, good. Now, central nervous system then has what is called the peripheral nervous system, or the PNS. The PNS literally is the rest of the body. Okay? So the brain speaks to the spinal cord sends information out to the PNS, or the peripheral nervous system. Is that simple? That's pretty easy, right? Everybody got that? Good. Let's break the PNS down to some more parts. All right, we're going to break the PNS down to 2 more parts, and I think we'll move it over here. All right. So the PNS is going to be broken down to the somatic nervous system and the autonomic nervous system. Somatic nervous system and autonomic nervous system. Your somatic nervous system is voluntary movement. Your somatic nervous system is voluntary movement. somatic nervous system, voluntary movement. It's also your sensory receptors. Your sensory receptors are all part of your somatic nervous system. Your autonomic nervous system. What's the key word in autonomic? Auto. It's the stuff that's done automatically. Autonomic nervous systems, things that are done automatically. It's your non-voluntary. Heartbeat, digestion, heart rate, temperature, those are things you can't control. The autonomic nervous system is then divided into two more parts, sympathetic and parasympathetic. Sympathetic and parasympathetic. Your sympathetic speeds things up. Your parasympathetic slows it down. So how many of you are afraid of giving speeches in public? All right, what starts to happen when you get up in front of them? You start feeling like, oh my God, oh my God. That's your sympathetic nervous system. It's literally speeding you up. You can't control it. You keep trying to calm yourself down, and it just keeps going up and up and up and up and up. You start doing that little shake thing. Your stomach starts hurting. You start doing that all stuff. Yeah, that's that. Then when it's over, you finally said the speech. You sit down. What starts to happen? What's the first thing you do? Whew. That's the parasympathetic. It slows everything down. Now it's taking the heart rate back down. Okay, before you take an exam, how do you feel as you click the exam button? Nervous. That's sympathetic. It's starting to, as soon as you click that, matter of fact, you probably gonna log on just before Monday, and you go like, I gotta take this exam. Sympathetic nervous system is gonna kick in with high gear. It's gonna have you feeling like you, oh my God, what's about to happen? What's she gonna ask us? Can I do it? When you finish that last question and push submit, parasympathetic is gonna kick in. But now you're about to hardly have a problem because now you want to know what your grade is, so they're going to battle. Make sense? Got the nervous system down? That was easy, wasn't it? So let's try this. My heart is increasing. Which part first is responsible? ANS. Heart is increasing, so which part of the ANS is doing this? I want to go play catch. Which part of my nervous system is responsible? What's it called? Somatic nervous system. Why is it responsible? It's voluntary. Yes? Good. We haven't got to the brain parts yet. We just Good. Got you got the nervous system down? All right, now let's move on. All right. Keep moving, so you don't even have to know that. Nope. All right, you do want to know this when we talk about brain imaging and techniques. In an effort to see the brain, we must use certain devices so that we can see inside of the skull to pick up different images. When we talk about a CAT scan is probably the basic unit that we use. CAT scan is pretty the simplest things. Usually when you hear and watch an ER TV show or whatever, first thing they say is give a CAT scan. It's simple. It just gives a computerized image of what's going on. We can't see activity. We can just see damage in regards to growth. We can see a mass, but it's your basic screen of brain activity is what I'll say. Basic screenshot. It's just a computerized screenshot. Your PET scan's a little bit more detailed. It kind of now starts to show me positioning of different things. The PET scan now starts to give me positioning. Your MRIs and functioning MRIs are the best image that can be given. It's going to actually show us where disorders, trauma is actually located in the brain. It's going to give us precise information. It's going to show me where exactly in what lobe, what region. It's going to give me precise information. The most expensive. Mm-hmm. it literally gives you almost like it's a grayish color, and you just see kind of like the shaping. It's like an outline. It's not giving you much. No, it's almost similar to a CT. It gives you just the basic, literally where I can see it and then say, you know what, I want to go ahead and do a functioning MRI because I see the black mass here. It should all be like a grayish white color. It gives you the gray matter look. So it gives you that soft tissue gray matter format. So if I see something black, now I'm going to say, let's go in and do a functioning MRI so I can see where this black mass is actually located. Oh, a whole lot cheaper. And that's why they say, you go fall off a dresser. I'm just going to use a dresser. That's not good. Fall off the ladder, hit your head. You're going to go to the ER, they're going to say, do a CAT scan. They will not say this unless you got some serious stuff going on and they've got to do it. They don't want to spend the money. And your insurance company definitely doesn't want to pay for it. Okay, that's because they're just cheap. But we're not going to talk about insurance companies because they might get really upset. All right, so let's now go parts of the brain. All right. First thing we have what are called sections of the brain. We've got 3 sections: hindbrain, midbrain, forebrain. Hindbrain, midbrain, and forebrain. Forebrain. Where do you think the hindbrain is located? In the back. Where do you think the midbrain is located? And where do you think the forebrain is located? See, that makes a lot of sense, right? So as psychology, they made sense. Inside of it, it has parts. These are your sections, but each section has parts. Follow? Okay. Inside of your hindbrain, you have 3 parts: the medulla, the pons, and the cerebellum. The medulla, the pons, and the cerebellum. Your medulla is responsible for your breathing. Your pons is responsible for your hearing and your balance. And your cerebellum is like your little brain. It has a lot of functioning activity. One more time, or you got it? Medulla, breathing and heart. Pons, hearing and balance. Cerebellum, functioning activity. Now, in regards to this test, there's going to be a scenario. It might literally say, Susie was on a roller coaster ride. She hit her head really bad. Now her balance is off. She can't walk. What part of the brain is responsible? Pons. So you make sure you pay attention. When it says parts, sections, regions, that really dictates the answer. You follow? Are you good?
Okay, so the hindbrain and fore would be the section.
Mm-hmm.
And then the medulla, pons, and cerebellum would be parts.
Yes. And then I'm going to teach you lobes and hemispheres. Got it? Good. Occipital, temporal. We're going to go through all of them. Keep it moving. Forebrain. Where do you think it's located? Forebrain. Now, the forebrain, that's a little kick. How many fingers can you put on your forehead? Hopefully. Hopefully just 4. If you got a 5 head, I'm not talking to you. I'm talking to the forehead people. Forehead, 4 parts. That might help you. Forehead, 4 parts. Okay? Here are the 4 parts. The thalamus. The thalamus is the first one. You're going to hear me talk about the thalamus again in chapter 4. I want you to know the thalamus is the switching system. The thalamus is the switching system. Now, what does it switch? The sensory information that's picked up by the body, the thalamus switches it to the message system to where the brain can understand it. So you touch something, the brain doesn't quite understand what you did. The thalamus actually switches that sensory information and allows the brain to understand what just happened. Remember we talked about the neurons, afferent and inferent? Remember those? All right, so we've got this neuron that went out. The hand touches it. The neuron is literally going to send the information back, but it's going to have to send it back to the thalamus so that the thalamus can understand and the brain can actually respond. Does that make sense? It's your translator. Your thalamus is the translator. That just popped in my head. Thank you. gives me messages. Got it? All right. Hypothalamus. This is probably one of the best parts of the brain that has the most activity. The hypothalamus does so much. And some of you are going to get kind of mad at your hypothalamus because you're going to start realizing why a lot of things you do happen. First thing, it regulates your body temperature. We know that's autonomic, correct? Motivation and emotion. You lack motivation, it's your hypothalamus that's doing it. If your hypothalamus does not create enough motivation, you're not interested. People who are emotional, it's your hypothalamus. People who are emotionless, it's your hypothalamus. Got it? It doesn't stop there. Hunger, hypothalamus. Hypothalamus tells you when to start eating and when to stop eating. And we're going to go to the next slide somewhere. And I'm going to tell you which part of the hypothalamus. There's literally a device inside of your hypothalamus that tells you when to stop and start. It tells you when you're full and when you're not full. But the hypothalamus just sends out a signal. All it does is send a signal out. It's the body's responsibility to say, are you hungry or are you actually just thirsty? Because the hypothalamus regulates both. This is why a lot of scientists say, when you feel hungry, drink a glass of water, wait 20 minutes, because if the hypothalamus was sending out a signal of thirst and you ate, it's still going to make you continue to eat because you have not sufficed the signal that was sent. But if it was just thirst, once you drink something, the hypothalamus will regulate and say we've got our needs met. We're no longer hungry because we never were hungry. Does that make sense? So some people just eat. You know, the signal come out and you're like, oh, I must be hungry. Grab something. Then you're like, I'm still hungry. No, you're not. You were never hungry. You were actually thirsty. Yeah, people always wish so. No. It just does what it does. It just signals out at 3 o'clock in the morning. Get up. Yeah. Or you just be like, oh, I just ran 5 miles. This piece of cake is nothing. You can't say that, but that goes back to the motivation. If the motivation is high, the hypothalamus will buy in. So can you trick the brain? Yes. You've got to trick the brain and say, this is so much more important than this that I want you to pay attention to that. Perfect example, when you walk into class, how many of you have math class? Just how many of you ever took a math class? All right, let's start there. I was hoping somebody said yes. What happened on the first day? Matter of fact, before you even walked into the class, it was on your schedule, and you looked at it. What'd you say? Oh, God. Lord, help me through this math class. Guess what the brain just said? The minute you said that, oh, my God. Guess what the brain said? We don't like this. Shut it down. When he walks into this math class, you don't understand nothing. So walk in, and the first thing the trader says, you don't understand it. Not even his name. So you walk down the hall like, him right there. Your brain shut down from before you even got there because the brain was tricked to say we don't understand it. When you like something, guess how easy it is for you to learn it? Because you like it. You trick the brain. Does that make sense? So you got to trick like when you wake up in the morning, you're like, this is going to be a great day. It might be the worst day you ever had. But when you finish, you was like, it wasn't that bad. Because the brain was tricked to pay attention. Make sense? The brain is a trickery thing. It tricks you to make you think you got deja vu, and deja vu doesn't even exist. Mm-hmm. It's the brain's way of saying, I need her to feel comfortable. I need her to feel comfortable. Take an old picture, take this picture, overlap it, give her a sense of comfort, and she's going to say she's been here before, yet she's never has. Never even seen it. But I need her to get comfortable right now. Trick her. That's how good the brain is. The brain will make you stop walking, yet you can still walk. As a woman, the brain will make you pregnant, and you haven't had sex. That's how good the brain is. Okay? I mean, your uterus will grow. You will start to produce milk. You won't have a menstrual cycle. You'll sleep a lot. You'll be physically pregnant. There's just nothing there. Your leg will hurt. You can't even walk. You'll be paralyzed. Phantom limb. Your whole arm hurt. You got your arm cut off 10 years ago. You can wake up and just stop talking. You want to speak, can't speak. The brain is good. Okay? Brain make you think you're sick when you're not. That's how good it is. It's all this hypothalamus. All right? It also does sexual behavior. Whenever you desire it, it's the hypothalamus fault. Because you lack it, it's the hypothalamus fault. So if you're in a relationship and you ain't never wanted it, it's the hypothalamus fault. Okay? It also does caring for offspring. Now, let's look at this because we got an issue. There's some people out there that sexual behavior is higher than the need to do care for offspring. They actually have the motivation is shifted, so depending on whatever the hypothalamus finds the most important to do is what they're going to do first. Does that make sense? You ever see people neglect their children for anything else, it's because the hypothalamus has shifted the need. You follow? And aggression. Every time you are angry, it's not your fault. It's the hypothalamus fault. So next time you get in an argument, just literally say, this is not me speaking. It's my hypothalamus, and I'm just responding. Okay? Because remember, you cannot control emotions. You can only control what you do with emotion. Okay? And it's the hypothalamus, automatic. But the biggest part we talk about is the amygdala. The amygdala controls all emotions. The amygdala controls all emotions. Amygdala controls all emotions. She is uncontrollable. You cannot control her. You can control what you do with her once she produces the emotion. Ever try not being angry? You're going to feel the anger, but you have to do something with the anger to calm her down. Okay? Every time you try, I'm not going to be angry about this, I'm not going to be angry about this, and it just keeps going and going because the amygdala does not pay attention to you. She is responding to whatever stimulated her. Okay? Now, once you start beating, kicking, throwing, that's you. That was a choice you made. No, you can't say whatever it's called. The amygdala.
The conscious or the unconscious?
Unconscious. She's technically both because she can consciously be aware, you just made me mad. Now she's about to just keep it going. The problem is consciously you can tell yourself, I'm not going to be angry. I'm letting it go. Well, she technically didn't let it go yet. So you're days later, it keeps rising because she hasn't been sufficed yet. Yeah, she's good. Love, or what we call love, it's her. Ever say, I'm not going to like them, and all of a sudden you keep thinking about them? That's her fault. Happiness, that's her.
So there's no way to know.
You could trick her. If you keep repeating it to yourself, she'll buy into you repeating it. But she has to hear you. So if you keep saying it, like, I don't like that, I don't like that. If she hears it, she'll believe it. You can always trick the brain. It just takes some manipulation to do so. But the problem is, she's pretty clever. So you'll be thinking you're tricking yourself, and 2 years later, it'll pop up. Unfortunately. Yeah, you'll be like, I don't like them. And 2 years you see them and they walk by you like, oh my God, what was that? That was her. She was just waiting for the moment to really screw you up. She's that good. Okay. Your hippocampus is your memory. It is the ability to take short-term to long-term. Your hippocampus controls memory. It switches short-term to long-term. Some of you have a problem here. The hippocampus isn't working. Okay? If you have a problem remembering short-term to long-term, it's the hippocampus. Hippocampus is destroyed by one drug first before any other drug. And what do you think that drug is? Marijuana. Marijuana destroys the hippocampus first. This is why they always say there's nothing wrong with it. It doesn't affect a lot of the other parts because it's so busy destroying the hippocampus, it's not worried about the other parts.
So the hippocampus switches
Short term
to long
to long term. Ever watch a person or meet, who knows, this is going to be you telling all your family members or your friends, Who knows a marijuana smoker who's been smoking for quite a while? All right. Now, what happens when you talk to them?
Have trouble remembering.
Okay. Or they'll tell you it don't even matter. It don't even matter. It don't matter because they can't recall it. Okay. It just takes away the memory part. They might even remember short things, and then some things it's just they can't recall it. Okay. And they will never get it back. Once the hippocampus is destroyed, it's gone. All right.
Can the hippocampus be affected by stress?
Yes, because it takes away concentration. So if the hippocampus cannot focus, it's gone. Oh, you can also strengthen the hippocampus. Everybody, remember back in the day, some of you might not have played it. It might be me telling my age. We had this little game called Memory. It had these cards, and you flip all these cards over, and you had to flip them back and guess it. That strengthens your hippocampus. You thought you were just playing a game, but technically your parents were strengthening your hippocampus. What we tell Alzheimer patients to try to help them, we tell them write 3 things down on an index card every morning. You start off with 3 things on a card, any 3 things you want. By the night, just before you go to bed, you must say those 3 things you wrote on a card without looking at the card. It's really strengthening the hippocampus to keep recalling and working. One way you can find out how hippocampus is destroyed, ever stop going to school and then start coming back to school. And watch how it takes you a minute to get back into the whole remembering things, especially if you work in a plant format. You just start going to automatic. You just start being automatic. You just start moving. And when somebody starts to say, now I need you to actively remember, you're like, oh my goodness. The hippocampus is like, we've been sleeping for 15 years on the job. We just knew what to do. Now you want me to actively do things, and it takes a minute for the hippocampus to wake back up. Ginkgo could go both. What's that word called? What's that stuff called? There it is. That and St. John wort, whatever he called. St. John and those things help memory and the hippocampus. I'm not a medicine person. I'm more of an herbal person, so I'll give you the natural part, and those work. Now, there are some prescription drugs that help, but I don't.
Where I'm from, it's funny because usually people when they start going to school, even they're like 6 years old, they like start giving them like vitamins for that.
Yeah. Mm-hmm.
So I wanted to make sure if that's correct.
Vitamin D intensifies the ability to concentrate. So the vitamins are not really not helping the hippocampus. They're helping concentration. They're helping health, because the minute that you're sick, memory's gone. Ever have somebody, you got a cold or you feeling horrible, and somebody say, remember this number tomorrow, okay? You're going to look at them like, yeah, okay. Call me tomorrow and ask me for it. Because health has to be. So they're trying to strengthen. The immune system is another. The immune system affects memory, because it creates other viruses that can actually destroy memory.
So the short-term memory can be inherited.
Mm-hmm.
There's one you don't mind sure that he's like, I'm gonna remember this in an hour, and I asked him like, what was the thing like? What are you talking about?
Once the short term is gone, short term, and you'll learn it in chapter 5 or 6. Short term memory only lasts 30 seconds. After 30 seconds, it's gone, and it only holds 9 units. 9 units is literally one number. So every number you give, you take out a space of short-term memory. You only got 9 units. So if I put 9 units in short-term memory for 30 seconds, after 30 seconds, it's gone. So if you start talking to me, the units are dropping off as you talk, unless I keep repeating it. Every time I repeat it, the 30 seconds starts over. So the minute we start talking, a lot of you like now, you're holding all this information I'm telling you in short-term memory. You're going to walk out the door in 30 seconds. You're going to get that phone call, and then you're going to get home. They're like, what'd you learn? Some memory stuff. We did the brain. Yeah, the brain. It's got a lot of parts. Yep. Yeah. I'm going to tell you the best way to learn anything. This is what the brain likes. The brain likes music. The brain loves music, and the brain loves stupid stuff. The stupider it is, the more the brain likes it. Like, for instance, in math class, what's the order of operation called? How do you do it? What do you use? But how do you remember it? Don't none of y'all got an Aunt Sally. But the minute they said, please excuse my dear Aunt Sally, it's stupid, so the brain like, we like that. That's dumb. Remember that. Okay, the songs that you listen to on the radio, Monday morning, they play that song. You hate that song. Friday, you get in the car, because they didn't play it Monday, Tuesday, Wednesday, Thursday. Friday, you get in the car, and you like, yeah, I know it. You singing it. You like, I hate that song. Because the brain said, it's got music. We hold to it. Television, commercials know this. Remember we talked about those IO people? They know you like music. So what do? Every jingle that they need you to remember, they put it to a song. Let's, for instance, say, it's just a blue screen. I'm not going to say nothing else to you. I'm just going to put a blue screen on the TV. And I'm going to tell you, I am on your side. Who am I? Nationwide. I didn't tell you nothing. All you know is Nationwide is on my side. You just saw the blue screen because the brain said it's got music. Okay? If you YouTube anything in this book, it actually has a song that somebody has done for you to remember. All of the founders actually has a song on YouTube. They sing the song, you know the founders and what every person does. Parts of the brain, it's got a song. You listen to the song, you know all the parts. You think I'm playing, but you'll be in the final exam singing songs. Think about how this worked. Back in kindergarten, you learned a song that you still sing today, and you ain't been in kindergarten in a very long time, but y'all like A, B. Somebody say the alphabet. You gonna say A, B, C. I said say it. A, B. You still gonna sing it. Twinkle, twinkle, little star, head and shoulders, knees and toes. They put music to everything because they knew you remember it. So if you got a test that's about to be really hard, sing it, and the brain will be like, I like that. We often tell people when you study, listen to a playlist while you study. The brain will start to associate the information to the music. When you take the test, play the exact same playlist because it'll trigger the memory the brain just associated with the music. So you can always trick the brain. But if you're smoking, you have to take your test while you smoke. If you drink a glass of wine studying, you have to take your test with a glass of wine. You drink Mountain Dew while you study, you must take the test with Mountain Dew. Because what happens, the brain only remembers when you take it back to its chemical state. It associates it back to the associated state. Animals trigger caregiving. It also triggers nurturing. There's two things that every advertisement will use to produce more sales: babies and animals. Perfect example, how many of you can watch TV, you can watch the war, you can watch all of this shoot it up, bang down, but when they put that commercial on with the dog, with the one eye that's going down, and he looked like he in the cage, and you like, oh, you just didn't watch people got beat up, shot down, killed, dragged out. You didn't watch them get executed, the serial killer and took the whole town on. You like, this was good. The minute that little dog got on, you like, oh, turn the station, I can't watch these dogs. It's just pulling on that nurturing. It's like it's helpless. And our idea of an animal is that it's helpless. Babies are helpless, so we always want to protect, protect, protect. And that's what it does. It's a natural instinct of humans to protect. The homeless man, he might not have no food, but he will have his dog. And it also because it gives us companionship. And you'll learn it's a basic need of life. Intimacy is a basic need of life, and animals give it to you. It's the unconditioned. If you got a dog, you know, you can screw up, jack up, mess up. That dog thinks you are it. Okay? When I walk in the house, my dog swear I walk on water, and probably have to be with my boyfriend all day who don't do right by the dog. When I walk in, he like, she here. Like he doing flips, he run around, tail wagging, he jump up. he's just amazed. And I feel like, oh my God, if don't nobody else love me, Max do. And I don't care when people say he don't have feelings. Max got feelings, and it's love for me. Okay. The limbic system. These are the things that control how you talk. Okay. Broca's and the Wernicke's area. Broca's area allows you to understand speech, while the Wernicke's area allows you to speak. Broca's understand speech. Wernicke's allows you to speak. Broca's understand or comprehend speech. Wernicke's speak. If the Wernicke's is messed up, you will not be able to talk. You'll kind of just do some babbling. If the Broca's is messed up, you'll hear information, but you won't be able to comprehend what somebody is saying. People will talk to you, you won't be able to understand it. Got it? Good? Good. Let's keep it moving. Okay, cerebrium. Understand this. This is the basic part of your life existence. If you don't have it, you're messed up. It's responsible for thinking. Okay? You've all got a brain. We all agree. That's just some tissue. But if you don't have a mind, that's a totally different statement. Brain is the tissue, mind is the functioning. And the cerebrium actually does the functioning. It's your ability to think. Now, inside of the brain, we have two hemispheres, right hemisphere and left hemisphere. They are joined together by what is called the corpus callosum. The corpus callosum is that indent. When you see the brain pictures, you see that little valley is what we want to call it. It's your corpus callosum. It's the indent between the two hemispheres. The corpus callosum allows the right brain to talk to the left brain. Okay? The corpus callosum allows both sides to communicate with each other. Okay? Right hemisphere controls left side of the body. Left hemisphere controls right side of the body. Right hemisphere controls left side. Left hemisphere controls right side. Yes, got that? Left side controls logic. Right side controls creativity. Everybody in this class is either a right side brain person or a left side brain person. If you're a logical person, you are an analytical person. You do things by directions, concrete examples. If you are a right side, you're more creative, you're more artistic, you're more shapy person. You want to see things, touch it, feel it. If you're more L brain or the logical side, somebody can describe it to you and you got it. There's actually a test you could take to figure out if you're left or right side. Creative. Artsy, logic. I'll print it. It's a print test. I might even have it up here. And I'll just give it and you just write it and it tells you. Once you know which side you are, you know at that point in time you must study according to what side brain you are. So if you're right side, reading all of this stuff, you'll never get it because you're not a logical person. You're more of an artsy person. You got to do it. You got to see it played out. If you're logic, reading it, writing it, repeating it, you got it. You got to always have a dominant. You have to have both to function in the world, but you're going to have a dominant side all the time. If you don't, you therapy. You want to keep one dominant just so that you always know. One way you can tell if somebody reads directions to you and you're like, what? Let me see it. Let me see it. You're probably going to be a right brain person. But if they can read it to you and you're like, got it. You're probably illogical. You're an analyzer. You're really quick at analyzing things. Okay, you're the type of person somebody tells you something, you're like, that quite doesn't make sense because it's impossible, because statistically, blah, 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 and blah, 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 blah. You're probably an L brain person. Okay. Now, let's go to the four lobes. We've got four of them. Occipital, located in the back of the head. Occipital is located in the back of the head, responsible for vision. Occipital lobe, back of the head, responsible for vision. There's a key word in there. You see that OC? OC at the doctor's office represents the what doctor? The eye doctor. Okay, occipital lobe, back of the head, responsible for vision. Temporal lobe, side of the head, right around those temples. It's the temporal lobe. It's responsible for hearing It's also responsible for language comprehension. It's responsible for hearing and also responsible for language comprehension. Parietal, top of the head, picks up all your sensory information. Parietal, top of the head, picks up all sensory information. Parietal, top of the head, all sensory information. Frontal, front of the head, responsible for motor, movement, thinking, and memory searching. Frontal, motor movement, searching memory, and thinking. I probably said those out of order, but you got them. So when you take a test and you cannot recall, what's the movement that you do? What do you all do? You're beating on that frontal lobe like find it, memory search, find it. That's because that's his duty.
So the frontal lobe is for memory and what?
Thinking, memory, search, and motor movement. Got the lobes, got the sections, got the parts, got the hemisphere. Temporal, temps, side. Best way to do it, remember when you were a kid and you were like, I don't want to listen, I'm not listening to you, I'm not listening to you. Temporal lobe, hearing.
So thinking, memory, search, and what?
Thinking,
I got that.
motor, movement. All right, so you've got lobes, hemispheres, sections, regions, parts, nervous system. Got that? You did all that already. Good? Now, this is what we call the geographic cortex. Remember I told you the brain handles everything? This is actually the map of the brain and the parts it actually handles. Sometimes you'll see people do brain surgery. They'll actually put a halo on the person, keep the person awake, and go in and actually touch the brain parts. Once they touch the brain parts, they can actually make a person speak, they can make a person lick out their tongue, they can make a person lift up their leg, all by just touching parts of the brain based on the strip. Because the brain actually is the sensory or the final point of everything you do. Does that make sense? Got it? Good. Keep it moving. True. Yep. Like that's what, when people always go brain dead. Once you're brain dead, it's functioning, everything is down, so you can't separate. It can't just do its own. Language functioning. So we talk about left and right brain. Let's keep it moving. We talked about that already. Keep it moving. We talked about that already. Left brain, right brain. We talked about that in your hemispheres. Left-handed, don't worry about that. Split brain, you need to know. So we've got this right and left hemisphere, correct? Everybody agree? What's in the middle? Corpus callosum. In people who have epilepsy, they sometimes cut the corpus callosum. They sometimes cut or split the corpus callosum because it will stop seizures. What it allowed the seizures to do is stop because they stop the communication between the two. So when you do a split brain research, there's a problem because right side controls what side of the body? The left, and left side controls what side? Right. Now, right side picks up what? What type of information? Okay, but what is it? What does the right side pick up in regards to? What do you notice? It's the creative side, right? So it's probably going to do your shapes and things like that. Do we all agree? Left side's going to probably do what? Logic, your understanding. So we just did a corpus callosum split. We got a split brain, and we've got a book. I'm going to place this book in front of a person who has split brain. I'm going to place the book over here. What side of the brain is picking it up? Left side. So what do I know this is? Logic. So when you say, what are you holding? I'm going to tell you it's a what? A book. What shape is it? Will I know that? No. What do you do with the book? Read it. Will I know that? I probably will know. Read the book. It has information. What color is it? Do I know that? No. All I know is it's a book. You should read it. Left side of the brain picked the information. I'm then going to have to switch over here. Now who's picking up the information? Right side. What does the right side pick up?
Creativity.
It's creativity. So what is it going to tell me? color.
What is it?
It's square. What do you do with this?
I don't know.
I can put only if I can relate to it, because normally your creative side is what picks up your color. Yeah. So what will usually you'll see a person has split brain, they'll do things like this, because what they're trying to do is to get each side to pick up accordingly. So they'll do it really quickly, and you'll think that they're just what they're doing is picking it up so both sides can pick up their individual information, and then they can tell you what they have. But if they hold it like this, they're only going to see what that side picked up. Split brain research. Yeah, split brain research. They still do it now. Epileptic individuals will still go through a split brain research project. Okay. Endocrine system. Not a lot I want you to know, but there's a couple of things. These are your hormones. Everybody has heard this before. You know hormones, correct? Hormones regulate a lot of stuff. They just don't correct those things that you thought they was regulating. They regulate some other things. Growth. We've all heard this. When you turn 13, some things changed. Some things you might have wanted to change, some things didn't. It's because of your hormonal production. Okay, metabolism, affected by your hormone producing. Okay? Thyroid is what's going to produce some endocrine system, and we're going to go through a couple of them. These are all of the glands that produce hormonal production. Your pineal gland, the hypothalamus. Remember, the hypothalamus is controlling hunger, so it has to produce a gland production. Pituitary gland, parathyroid, thyroid, the thalamus. All these things are actually producing different type of hormones that produce different things inside the body. Does that make sense? Everybody got it? All right. If you see down at the bottom, your ovaries and testes, they actually produce a hormone. We'll talk about those people who are called intersexed or hermaphrodites. Your hermaphrodite usually only obtains one sexual organ internally, but they have both sexual organs externally. But there are true hermaphrodites that will contain both hormonal productions on the inside, because they will have ovaries and testes. Very small percentage of hermaphrodites are true hermaphrodites. Okay, most of them only contain one gland on the internal organ side. Okay. Pituitary gland, you need to know, this is really your master gland. It really performs a lot of the duties. It's just below the hypothalamus. It is literally your master gland. It produces most of your duties. Pineal gland produces melatonin, allows you to sleep, and it also allows you to wake up. Some people suffer from insomnia or narcolepsy. It's literally the pineal gland that is affected. They'll take a drug that will actually regulate the pineal gland production of a hormone. Right. Thyroid actually affects the metabolism. You can have what is called hypothyroid or hyperthyroid. Either your thyroid does not work effectively, or your thyroid doesn't work, it overacts. People who actually have a hyper or hypothyroid sometimes have to go through radiation treatment just so the thyroid can be slowed down or sped up so that it can actually function. Those people whose thyroid is functioning too fast will lose about 25 pounds a month, just because the body always thinks it's exercising. So their body is in constant exercise mode, heart rate is always increased, and they're just, more they eat, they're always hungry, because the hypothyroid is actually consuming a lot of the production for energy purposes. Okay, very serious illness. I have two cousins that had it. They couldn't go to the airport for a year. They couldn't be around children under the age of 5 for so long. They couldn't go through the airport because they would set off the detectors. One of them, he couldn't be around pregnant people for 2 weeks, so he actually had to go into a hotel room because his wife was pregnant at the time. Literally because his body would start generating the radiation that he was producing just because of his thyroid to slow it down. He literally lost 25 pounds in the first month of the thyroid happening, and I always felt like he was exhausted and tired because the thyroid was too hyper. Okay. Adrenal gland, know that this is what actually happens during stress. Stress situations increase adrenal gland production. I'm sure all of you heard of cortisol and all of those different products is literally based on the adrenal gland. The more stressed you are, the more cortisol that your body will start to produce, the more weight you'll start to increase, the more hard times you'll have concentrating, immune system will decrease. A lot of things happen from the production of this hormone. Mm-hmm. The medulla is different. Totally different. Steroids, we don't really talk about steroids. Testes and ovaries, know that men have testosterone, women have estrogen and progesterone, or what we call progesterone. When we talk about testosterone, it's produced by the testes. Okay? Men also deliver testosterone in their saliva during kissing to intensify a woman's sexual desire. So when a man kisses a woman, he actually passes her testosterone so that he can increase her sexual desire, because she does not produce the testosterone on her own. Okay? Estrogen is a female hormone. It starts to decrease as you age. All women in this class, no matter what you do or who you are, where you were born, who your mama is, you're going to have an estrogen decrease at right around the age of 45 to 50. It's going to start to go even lower, and it is when you call menopause. Okay? It will produce such a decrease that you start to change mood-wise, hormonally, physically, all because of your lack of estrogen. You'll start to grow hair in places you never grew hair before because there's no longer estrogen production. They do give you supplements for that as well. All of you, your mothers might be going through it now or planning to go through it. It's the time where her moods change drastically. She gets a little emotional. She gets a little angry. She will go through this for 10 to 15 years. Okay, before the estrogen level will start to finally say we're done. It will actually start to happen when all of the ovaries are gone, or what we call ovums. Ovums is the female egg. A woman is born with 500,000 ovums on her day of arrival. So once all her 400, 500,000 run out, that's when the estrogen will start to decrease because it has no more purpose for production of pregnancy. Okay. Hysterectomy. Usually you'll go through menopause faster. You'll hear people talk about partial hysterectomy and hysterectomy. Usually if you give a full hysterectomy, you're going into menopause right after the hysterectomy. And it's literally because the estrogen levels decrease. Yeah. But estrogen and all of the natural supplements kind of keep that balance so that you don't have the heat, they call them flushes, but you hear your mother say, I'm flashing. She's really flushing. And she's having a summer. Her body literally is about 95 degrees outside temperature, but yet it might be 20 degrees in the house. And she's just feeling, it's just something she got to go through. And some do it really well. Some people go through menopause without any problems. Most people have slight problems. And then you have what's called perimenopausal, which is literally those people who start menopause as early as 30. Usually they start to take that because they get that. If your mother is like irritated about everything, she's probably starting. Just know if you're a woman, you're going to go through it too. You just look at her and just go, oh my God, her estrogen levels are low. She ran out all her ovums. No more menstrual cycle, no more pregnancy, and she's just going through her changes. Okay. Evolution, keep moving. Oh, you do want to know, we talk about evolution and the idea of struggle for existence. We actually found out that the body is amazing in regards to your mate selection. Okay, when we talk about mate selection, we actually found what's called natural selection. We are individuals who will actually adapt to survive. And we find individuals that will assist us in our adaptation. Does that make sense? We adapt to survive, and we find individuals who will assist us in our adaptation. I can put you anywhere in the world, and you will adapt in an effort to survive. If everybody's seen Survival, it's the reason why it's called survival. You will adapt to survive. If I put you in the jungle, you will figure out how you will adapt to survive, even if it means eating each other. You will eat bugs you never thought you would eat. The roaches will become your snack. Okay? The tree bark will become your meat. I don't know what you're going to do out there, but you will survive. Okay? You will also start to mutate. Every individual will mutate. Of course, some of y'all looking like, oh my God. You will mutate to your environment. If we put you over in some of the areas that has the hottest temperature, your hair will usually probably start to either thicken or thin in an effort to keep you cooler. Okay? Your skin color will change due to the environment. You ever heard people say they must be married? They've been married a long time. Why they been married a long time? They start looking like each other. You start to mutate. Okay? Somebody can be adopted, and you've been with this family for 30 years, and every time they see you, like, she look just like her mama. She mutating. Okay? If you ever learn, I'm from the north, but sometimes when I talk to my mother, I have picked up some of the southern terms, and she literally say, what in the world have you just said? I'm starting to mutate. Okay? When I go home for Christmas, it's freezing in Detroit. I lived in Detroit my whole life, minus a couple of years. But when I go home, it's now freezing because I've mutated that the cold weather consists of 2 inches of snow. I go home, it's 2 feet of snow. And I'm like, oh my God, it's freezing up here. Where's my scarf? My mother's like, girl, this is good weather. We putting our shorts on. No, we not. Okay, I'm starting to mutate. Does that make sense? Okay, good. Instinct. Understand we all have instinct. It literally is a stereotypical pattern to do something. All of you have instinct. It's a stereotypical pattern to do something. It's a way that you have learned that works. All right. Heredity. Understand when we talk about heredity and genetics. There are a lot of things that you do in regards to even your intelligence. Intelligence is actually a hereditary and a genetic link. We have found that intelligence is a genetic link. Your parents have actually transmitted a lot of different things through offspring. That genetic makeup is based on the genetics your parents have passed to you. Addiction is actually hereditary. Intelligence is hereditary. Yeah, you got a lot of diseases that are hereditary. And literally you just watch it. Surprisingly, even things like gallbladder removal and weakness is hereditary. High blood pressure, hereditary. Cholesterol problems, hereditary. It's just literally you've got a lot of things that you find. Breast cancer, they've actually found out more and more. It's hereditary. So you find a lot of things that are based and literally given based on genetic makeup. Okay? Schizophrenia, hereditary. Okay? Healthy eating, like I know a lot of times we've actually found that stress increases cancer production. So what they've actually found is sometimes when people have a family that have a history of cancer, the stress and the worry has actually started to trigger the growth of the cancer. So it's really like we tell them like the whole healthy eating and then making sure you get checked because that's huge. Other than that, some of the things you just gotta buy. Especially being a woman, it's the woman's side. You might not be affected because it is a woman's link in regards to the genetic makeup. When we talk about the whole idea of hereditary, we're talking about genes and chromosomes. Genes are literally the basic unit. Chromosomes are the structure. You're going to get 23 from each parent, making a total of 46. Each parent, when they decided to get together, sperm had 23 chromosomes, the ovum had 23 chromosomes. I always tell people it's like playing craps. You might have 2 white parents that have a black child, and you think something just happened. No, what could have just happened? You start questioning what did she do? She did nothing. What happened is when they start playing the crap game, somebody reached way back and grabbed some of them chromosomes that belonged to Uncle Petey and rolled them out. Okay? You might be the only person in the family who got red hair. Everybody else got blonde hair. What happened? They reached back to Aunt Sue and rolled them out. Mm-hmm. Mm-hmm.
What happened with you? What happened? And my mom said, stop. Why do you look like that? Well, because my dad is American, but we never know him.
The 23 chromosomes, when your sister decided to start playing crap, she was just like, let me see what I can get. What can I get? Rolled them out, and she rolled out blonde hair, blue eyes. She just, it can happen. So literally when people be like, they don't look like nobody in the family. They look like somebody. It's just you didn't know them. Okay? It just happens. Even with, I've got 4 brothers and sisters. Me and my sister have different mothers, but if you look at us, we look so much alike. That's because my dad's chromosomes are strong, dominating chromosomes that just wipe out everybody else's chromosomes when they get to them. So when his little chromosomes meet somebody, they just devour them, and they just all look like him. He got some dominant stuff going on, and this is gonna sound really bad. I can't put that on tape. Yeah, so down 21st chromosome. If you have any Down syndrome in the family, the 21st chromosome has an extra chromosome. So instead of having 2, they have 3. Okay, your chromosome pairs kind of pair up to where they start looking like this. So literally you have an XY. We know this is a male child because only men can make male babies. Women cannot make male babies. Women can only make female children. So it's the male that determines the sex of the child. So when the sperm came about, I'm gonna just make some sperm, it was a Y sperm. The Y chromosome got with the X chromosome, created a male child. We know this is gonna be a boy child. All these other links could be hair color, eye color. All these are just links that chromosomes have just linked together. So now when a person does, we can actually take this blood test prior to the baby being born and be able to tell you everything this baby's gonna have just because we've looked at the chromosome patterns. Because all we're going to do is look at this 23rd chromosome, and it's going to look like this. You've got a Down syndrome baby. Currently, in an effort not to take a blood test, they're going to do what is called a structure scale, where they're going to do the measuring to see if the base of the head is larger. The problem is it's always usually wrong to where it looks like it and technically is not, but it's a chance. All of your Down syndrome children will all look alike, regardless of ethnicity. If you ever look at your Down syndrome, they're all going to look alike. Unfortunately, they don't live past usually the age of 46 because it is a weakening in that chromosome. Okay. DNA, you all heard of that. It's not to test. It's literally DNA is literally to test to see chromosomes. This is why HIV is such a great virus. It is probably one of the most extravagant viruses is because it does link to DNA. And what it does, it changes the molecule function to look like DNA. So when the virus tries to mutate or somebody tries to go in to kill the virus, it mutates itself to look like a strand that is already present. That's why it's such a sophisticated virus. But that's really what we call your DNA. You can kind of figure out who's your parent off from those chromosome makeup. You know genotype and phenotype. Genotype is literally your genetic natural makeup. It literally is what naturally is given to you. So let's just say things like blood pressure, cholesterol, that's that genetic place, that's your genotype. Phenotype is the appearance that you look like. Your nose, your eyes, that's your phenotype. Genotype is literally the genetic nature part. So you might be prone to be tall, that will be your genotype. The phenotype might be the way you're shaped. Everybody in this class, some of you might diet over and over and over again. Trust me, I know. You won't lose nothing. It's just a genetic makeup. Okay? Got it? Good. We talked about all of that already. XX female, XY male. Down syndrome is on the which chromosome? 21st. I'm sorry, you guys. It's the 21st chromosome. Make sure that's 21. Monozygotic and dizygotic. When a sperm hits an ovum, this is my ovum, which is sometimes people call an egg, and this is sperm. When they meet, they create what is called a zygote. Okay? Sperm and egg meet, create zygote. If the zygote splits, one sperm, one egg, split, you have what is called monozygotic twins. One sperm, one egg splits, monozygotic twins. They will be the same sex child because they had the same egg and same sperm. Do you follow me? Okay, so if a Y sperm hits this X egg, you're going to have, and it splits twice, we've got two boy identical twins. Monozygotic twins, they share the same DNA. They share the same chromosomes. If we take their blood, they can both be the father. You see Maury. identical twins, they both gonna be the father of that baby because they share the exact same DNA. We're gonna have to do some more testing to see who's the actual father because they share the exact same DNA. Dizygotic twins, it was 2 ovums. That's a Jerry Springer episode. This is why you can have dizygotic twins with 2 separate fathers, because dizygotic twins mean 2 eggs, 2 sperm. They're technically just siblings that resided at the same time. Dizygotic twins are fraternal twins. 2 eggs, 2 sperm. They can be 2 different sexes. They can be 2 different parents. They can be 2 different colors. They are just siblings. Monozygotic twin, identical. Monozygotic twins usually share more of the same things. One has high blood pressure, they both got high blood pressure. One is intelligent, they're usually both intelligent. They've done studies where they've split monozygotic twins on different sides of the country, and they like the same things, they did the same things, they scored the same things, they invested in the same things in regards to partners because they share exact same DNA. Monozygotic, 1 sperm, 1 egg. Yes, have to be the same sex. Dizygotic twins can be different sex. Yes, yes. Your monozygotic twins play that role too in regards to dominance, really based on their positioning, because their personalities can be. You can have monozygotic twins that have different personality types, but depending on their positioning inside of the uterus, one usually is going to protect the other. Yep. So usually when they come out, you'll know which one was probably in the front, because who was in the back is probably going to be very quiet, more the submissive one. That dominating one is going to be a protector, and they're going to do it when they come out. They're usually your loudest twin, the more, outgoing twin, but they're identical. And we've done chapter 2. Woo! Success. And we're over 15 minutes. Why didn't y'all stop me? Y'all got to stop me because I'll be like, all right, we're good. Now, chapter 3 is a very, very long chapter, but you get 2 days to do it. So you don't feel rushed in chapter 3, but bring chapter 3 on Monday. You've got 2 days to do it. It's a long theory-based test, but we're good. By Monday, do your exam 1. It's on chapter 1 and chapter 2. Exam 1 is on